One of the main ideas we use in any kind of a math course in high school or beyond is actually modeling with mathematics. So we're going to be looking at applications of parabolas, and this is basically using mathematical models to follow something that would have a parabolic path. So here's an example. So we have Tanya strikes a softball from a height of 4 feet above the ground. So he hits the ball. The ball reaches a maximum height of 53 feet after it has traveled 75 feet from the plate. If the ball is at least 8 feet high at 140 feet, Tanya will hit a home run. Does Tanya hit a home run? We're going to justify our answer. So let's get our information from the problem. So first of all, we know she hits it at a height of 3 feet above the ground. And when it's traveled 75 feet down the fairway, it reaches a height of 53 feet, 75 feet away from the plate. So this tells me I have a vertex at 75, 53. So I'm going to put it into my vertex form of the equation. And again, just in case we need little reminders, vertex form of a parabola is y equals ax minus h squared plus k. And that's my vertex is at h comma k. So my vertex is at this point 75 comma 53. Now be careful, make sure your units all match. They have to all be the same units. This is in feet, this is in feet, this one's in feet. Sometimes you'll have to do a conversion to make them all the same units. Okay, if the ball is at least 8 feet high, when it's at 140 feet, she hits a home run. So what I've got to do is figure out what my equation is, which means I got to figure out what this A value is, and then I'll plug in. So I need a point that the graph goes through. So I'm calling this point right here where her foot is, right where the ball was hit. That's the point 0, 0, which means this point up here is the point 0, 3. So x is 0 and y is 3. I need to have some of the point that my vertex will solve for A. So we're going to plug in. So when x equals 0, y equals 3. We do negative 75 squared, gives you 5625. So 5625a plus 53 is equal to 3. Subtract 53, divide by 5625. And if you do reduce it, we have 5 will go into both of these. Actually, 25 will go into both of these. You get negative 2 over 225. That means my equation is y equals negative 2 over 225, x minus 75 squared plus 53. So this is based on where x is the horizontal distances traveled away from her. The y is the vertical height. Now I'm going to plug in when it's traveled 140 feet away from her to see if it's actually 8 feet high. So plugging in 140, we have 140 minus 75. We square that and then multiply it by negative 2 over 225, add 53. Pretty much we do this on a calculator. We get 15.44 feet. Since that's greater than 8 feet, I'm going to say she hits a home run. Okay, let's look at another example. So we have a wire that hangs between two 50-foot telephone poles. Oh, one comment before I move on. Notice how we have an upside down parabola. So one little check you should realize is my A value should be negative. So that's one observation. So if I didn't get a negative A value, it means I made a mistake or I plugged something in correctly. So in this example, we have wire hangs between two 50-foot poles. Middle point hangs 4 feet below the top of the poles. The two poles are 80 feet apart. I want to know what is the equation of the wire relative to the base of the leftmost pole. So I'm doing it relative to this point right here. That's what I'm going to call 0, 0. Okay, so plugging in, my information. I know the poles are 50 feet each. And then this middle point is going to drop down 4 feet from where the top of the poles are. The poles themselves are 80 feet apart. I need to figure out what is this vertex. So when I look at this, if this is 0, this is going out to the point 80, 0. The vertex is halfway between. So my x-coordinate is 40. The y-coordinate, well, this height here is 50, and I go down 4, I would have a height of 46. So that's where we had gotten that value. So it's 40, 46. And again, we're going to call that point 0, 0. Okay, plugging into our vertex form of the equation. So again, we're going to be using y equals a, which we have to solve for, x minus h squared plus k. My h is 40, my k is 46. Plugging in the point it goes through, which in this case is 0. This point I'm looking at, the x-coordinate is 0, y-coordinate is 50. I get 50 is equal to 0 minus 40 squared plus 46. When I do negative 40 squared, I get 1600. Subtract 46, divide by 1600. You get 4 over 1600, which reduces to 1 over 400. And there's my equation.